Welcome back to Physics Fun Time with
Ivan the Elephant!
and the Wizard.
Well, hello there, Mr. Wizard!
Well, hi there, Ivan. How's it going?
It's going good! I just have one question. It was 1 week ago. I was standing on a cliff next to the chef, and I was wondering how hard I'd have to push the chef to get him to fall off the cliff.
Well, that is an interesting question, Ivan. But first, we need to learn Newton's laws of motion. First, we have to define some key components of Newton's laws of motion. Ivan, do you know what mass is?
Well, yes! Isn't mass just an object's weight?
Are you some sort of stupid idiot? No. In fact, mass is a measurement of an object's inertia.
What is inertia?
Inertia is an object's tendency to remain at rest if it is at rest, or to remain in motion if it is in motion, unless acted on by an outside force. That is Newton's first law. An object at rest stays at rest, and an object in motion stays in motion unless acted on by an outside force. That is inertia.
But if an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an outside force, then what is that outside force?
Well, Ivan, a force is any influence that has the ability to change the motion of an object. Now, Newton was a smart man, and he figured out that force is what causes acceleration, and that force, the mass of an object, and the acceleration of an object are all related. He determined that the sum of the forces equals the mass times the acceleration of an object. Examples of such forces that are present in situations are
weight, which is equal to the mass times the force of gravity.
Okay, get off me!
Push and pull,
Oh no!
friction,
Oh, no, I don't want to go, no!
tension force, which is present in situations with ropes,
Are you sure about this?
and the normal force, which is the force exerted upon the object by the surface the object is resting on.
normal force is a great example of Newton's third law. That is, for every action, there is an equal and opposite reaction.
But with all those forces and laws, it's so confusing. How would I ever put all those forces onto paper?
Well, I've got some paper right here. Why don't I just show you? Let this square represent the chef on a two-dimensional plane. The force acting this way on the chef is the push force, or the force of the elephant pushing on the chef from behind. The force acting this way on the chef is the friction. That's what's keeping the chef from falling off the cliff. The force acting upward is the normal force, or the force of the surface on which the object is resting on. The force acting downward is the weight force, or the mass times the gravity, which is 9.8. That's the force of gravity on an object.
Thanks a lot, Wizard. I learned so much today.
Well, I'm glad to hear that, Ivan. Say, where are you going with the chef?
Well, I thought I'd switch.